First of all, let's start with an introduction. Our QMT system analysis is focused on Mixue, specifically the branch located at KS19, LG Floor, New Center Segamat, Jalan Utama 342, Taman Bandar Utama, 85,000 Segamat District, Johor. This outlet has an operating time from Monday to Sunday, starting from 10 AM until 10 PM. To gather our data, we conducted an observation from 1:50 PM to 2:15 PM. During this peak period, the store operated with a single server to handle all incoming orders.
I've never felt like this, I don't know how I ever survived without it. I'm starry-eyed, got me upside down, spinning around you. Wanna taste the clouds, dance with.
Next, let's look at the waiting line characteristic we identified. We found that the length of the line is considered unlimited, meaning there is no restriction on how many customers can wait at one time. In terms of queue discipline, the store practice first in, first out, or FIFO. This ensures that customers are served in the exact order they arrive, maintaining a fair and organized flow.
Moving on to the arrival characteristic. First, what is the size of the calling population? The size of the calling population is infinite, which means there is no fixed limit on the number of customers who can enter the system. Second, what is the pattern of arrival at the system? Customers arrive at the system randomly without a fixed schedule or pattern. This means the arrival time of each customer is unpredictable. Third, what is the behavior of the arrival exists? The behavior that exists is patient customer. The customers are patient, which means they are willing to wait in the queue until they receive service and will not leave the system even if the waiting time increases.
Next are the service facility characteristics. The first characteristic is the number of channels. The system operates with a single channel, which means there is only one server available to serve customers at any given time. The second characteristic is the number of phases. It follows a single-phase system where the service process is complete in only one step without moving to another counter. Lastly, the number of waiting lines show that the system has one single waiting line where all customers queue in the same line and are served on a first-come, first-served basis. This is the diagram for single channel and single phase system works. Show that customer first arrive at the system and enter a single waiting line which is queue. They wait in the queue until the service facility is available. Since this is a single channel system, only one server provides the service at a time. The system is also single phase, which means customer receive the service in one step only. After the service is complete, customer exit the system.
Next, we continue with data that we observe. The data show the flow of 30 customers at a single payment counter in Mixue. For each customer, the arrival time, start of order, order completion time, and service time were recorded. Most service time took 1 minute, but some customers had longer service time, such as customer 5, 8 minutes, customer 8, 3 minutes, and a few customers, which is customer number 14, 19, and 28, took 2 minutes, indicating variation in service speed. The time between customer arrival was generally 1 minute, showing a relatively steady flow of customer, but longer service time, queue, and waiting time. The data can be used to calculate average service time, average waiting time, total time in system, and counter utilization. It is used for analyzing and efficiency of queuing system and understanding customer waiting pattern at Mixue.
Next, the calculation for the queuing system. First, the number of servers is 1, therefore M equal to 1. The arrival rate indicates that customers come to Mixue at a rate of 30 customers per hour, hence lambda equal to 30. For the service rate, the total service time for 30 customers is 42 minutes, giving an average service time for 42 minutes divided by 30 customers, which is 1.4 minutes per customer. This indicates that the server can serve 60 minutes divided by 1.4 minutes per customer, which equal to 42.8571 customer per hour. Therefore, the service rate mu is 42.8571 customer per hour. This slide shows the performance measure of the queuing system using the arrival rate and service rate where lambda equal to 30 and mu equal to 42.8571. First, the average time a customer spends in the system, denoted by W, is calculated using the formula W equal to 1 over mu minus lambda. By substitute the value, we get 1 divided by 42.8571 minus 30, which equals to 0.0778 hours. Next, the average number of customers in the system, denoted by L, is calculated using L equal to lambda over mu minus lambda. Substitute the value if 30 divided by 42.8571 minus 30, which equals to 2.3333 customers. Next, this slide shows the average waiting time and the average number of customers in the queue. Using the arrival rate lambda equal to 30 and the service rate mu equal to 42.8571, the average waiting time in the queue, denoted by W sub q, is calculated using the formula W sub q equal to lambda divided by mu multiplied by the mu minus lambda. By substitute the value, this becomes 30 divided by 42.8571 multiplied by the 42.8571 minus 30, which equals 0.0544 hours. Next, the average number of customers in the queue, denoted by L sub q, is calculated using L sub q equal lambda square divided by mu multiplied by the mu minus lambda. Substitute the value, give 30 square divided by 42.8571 multiplied by the 42.8571 minus 30, which equals 1.6333 customers.
Now, let's get into the technical data. We identify an arrival rate lambda of 30 and a service rate mu of 42.8571. From these figures, we calculated the utilization factor for the system, represented by P. By dividing 30 by 42.8571, we get a utilization of 0.70 or 70%. Finally, we look at the probability of no customer in the system or P0. Using the formula 1 minus lambda over mu, we found that there is a 0.30 or 30% chance that the system is empty at any given time.
Next, conclusion. We can say the number of servers provided is sufficient to meet customer demand. Not only that, the system has a very low waiting time of only 0.0544, which allows customers to be served quickly and leads to high customer satisfaction. The servers are used efficiently without causing congestion. From a management point of view, the current setup is effective and does not need additional server, which helps to reduce costs. However, future monitoring is recommended to ensure the system continues to perform well if demand increases.
Lastly, what we have learned from this project. From this project, we learned how to observe and record customer flow at a service counter, including arrival time, start of order, order completion, and service time. Through our observation, we understood how waiting line form when the service time is longer than the time between customer arrival. Additionally, we learned how variation in service time and different customer arrival rate can affect the waiting time and the overall length of queue. Lastly, we learned how to analyze and explain the performance of waiting line queuing system